This is tutorial number 147 and it is the second tutorial in the sheet metal series. In this tutorial we are going to talk about these points. First, we are going to talk about some approaches when starting a sheet metal part drawing or design. There are many approaches depending on the shape of the part you are going to make. And then we're going to talk about the first command in sheet metal, the base flange, and we will see what will be new on the tree, on the SolidWorks tree when we are starting the sheet metal command in general. And then we are going to talk about the key factor and how it is related to the material properties. As we know, there are different sheets, for example, steel, aluminum, copper, and so on. And then we are going to talk a little bit about flatten. So let's go to this part which we have started. Go to sheet metal, and you see here the base flange. And beside the base flange, you will see convert to sheet metal, lofted bend, and then you have the forming tools. As you notice, we have only two commands which are activated and the rest are deactivated, and they will be activated once we start the sheet metal tree. So now let's talk about the approaches. When you start to draw a sheet metal, there are basically, according to the sheet metal menu, 4 approaches to start or to make a sheet metal product. You have the base flange, which is the mostly used, and it is almost 90% of the sheet metal products are created by the use of base flange. Then we have if you have a little bit more complicated shapes, then you have the lofted bend, or you can create it by other commands like solid feature, then convert it to the sheet metal. As you see here, convert to sheet metals, or by forming tools, which is kind of die mold. Now let's start using the base flange. At the beginning, to make it easier, you can imagine the base flange exactly the same like the extrude. To the sheet metal, we can press directly on the base flange, then we pick the plane we want to draw on it. I just click X, or we start as we used before, picking the plane that we need, then draw the shape. Let's pick the front plane, start sketch. I'm going to make a simple L shape. Let's give it some dimension. Let's give this 50 and here 25. Go to sheet metal and select the base flange. So as you notice, it just extruded the L shape with thickness. Here you see the base flange menu. I'm going to talk about the very basics for now. We are already familiar with. We're going to talk about the directions, the sheet metal parameters, and for the rest we are going to talk in the next tutorials. We are going to talk a little bit about the bend allowance, K factor. Now let's go back to the extruded sheet metal. Here you can pick the thickness. You have 0.75 millimeter. I can put it 1 millimeter. You can notice that the difference. Let's make it clear. 5 millimeter. You have the thickness of the sheet metal. Then you have the bend radius. You notice here we didn't add any radiuses at the corner, but this is the bending radius. It is logical when you are bending any sheet you get this radius, and here you can specify this radius if you already know the value. So let's put 2 millimeter for that bending. And then if you go to the very first option, direction, it is very similar to the extrude. You have plane, there you can increase the extrusion or the length of this beam, and then you have direction 2. We are already familiar with that. We talked about that in the extrusion. Also, you can extrude on the direction 2. Let's deactivate direction 2 for now. Here you have again the same options similar to what we used in extrusion. I'm going to pick mid plane, then you have your extruded part, mid plane extruded, and here you have under the thickness reverse direction, that where is your metal you need to be placed. If you reverse direction, you will notice the sheet metal is extruded inside. If you reverse direction, it will be outside the shape. And when we are done with this shape, click OK, and then we have our bended sheet metal. We talked about the base flange, a very basic explanation. Then we will have to look at the sheet metal tree. As you notice the difference between extrusion and the sheet metal, here you have 4 elements instead of 1 element. In case of extrusion, you have the cut list, then you have the sheet metal, the base flange, feature, command, and then you have the flatten. So these 4 starting every time you use the sheet metal commands. And here you notice the sheet metal commands are activated. The elements of the sheet metal tree, these 4, the cut list, the flatten, and sheet metal, we are going to talk about them in details in the next tutorials. But right now I'm going to just edit, as we learned before. When you need to edit any feature, go to the base flange and edit feature, and you will notice you have only the basic options are appeared, which we discussed. You have the extrusion distance, which you are able to change, and you have the thickness and millimeters. The reason for that is sheet metal, when you start the sheet metal commands, it assumes the whole part will be the same type of sheet metal, so there is no need to specify all the time the thickness and the bending radius, because it is the same metal or the same sheet metal. For some reason, if you wanted to change the thickness or the bendings radius, you can override the values over here. And again, as we discussed it before, let's just click OK. And to get to the sheet metal properties or the material properties, you have the sheet metal here. If you click on edit, and this part is related to the material properties. We said that we're going to talk about that in the later tutorials. A little bit about the K factor. So as we know, there are different types of materials, different materials for sheets. You have steel, aluminum, copper, and SolidWorks calculated the bending radius when you are bending a piece of metal. For example, when you are bending a sheet of steel, you will not get the same dimensions when you are bending a piece of aluminum, and that is defined by the bend allowance auto reliefs or the gauge table. So K factor, as we said, there are different materials. The harder the materials, the K factor will be bigger. Softer the material, the K factor will be smaller. This is a very basic explanation about the expectation of bending a sheet of metal. So now let's just click OK. And the last thing, we have the flat pattern. We will going to talk about that in detail in separate tutorial. The flat pattern, when you bended this sheet of metal, you can again return it to the original shape by unsuppressing this feature. This feature is suppressed on this flat pattern, and unsuppress, you will get again that piece sheet metal before bending. If you want to exit from the flat pattern, you go to the exit flat pattern here in the corner.